This is chapter 5-5, Inequalities in One Triangle, part 2 lesson. Okay? We'll look at theorem 5.12, which is exterior angle inequality. And it says the measure of an exterior angle of a triangle is greater than the measure of either of the two non-adjacent exterior angles. What does that mean? What's the exterior angle? The exterior angle, if we remember from the exterior angle theorem, is this angle 1 right here. And if you remember from the exterior angle theorem, that one exterior angle, angle 1, had to be equal to what? Angle A plus, I should put the measure of. The measure of angle A plus the measure of angle B. Added together. Okay? So the measure of angle 1, which is your exterior angle, had to be equal to angle A plus angle B. Well, all this theorem is simply saying is angle 1, the measure of angle 1, is greater than angle A by itself. And it's also saying that the measure of angle 1 is greater than the measure of angle, and that should be B. Okay? And that's true. Think about it. The measure of angle 1 is going to be greater than the measure of angle A by itself. Why? Because you have to add A plus B in order for it to equal the measure of angle 1. So again I say, the measure of angle 1, which is your exterior angle, the measure of angle 1 is going to be greater than the measure of angle A by itself. And at the same time, the exterior angle, the measure angle 1, is also going to be greater than the measure of angle B all by itself, because again I say, on the exterior angle theorem, you had to add both angles to even equal the exterior angle. Therefore, if I break angle A by itself, the measure of angle 1 is going to be greater than angle A. And if I look at angle B by itself compared to angle 1 is still greater than the measure of angle B. And that's theorem 5.12. And then let's look at theorem 5.13. There's a lot of writing right here. I'm going to draw little lines right here, and I'll uncover it in just a moment. But let's look at the theorem. Theorem 5.13 is the triangle inequality. The sum of lengths of any two sides of a triangle is greater than the length of the third side. What does that mean? Simply, I have triangle ABC here. And on triangle ABC, in order for this to be considered a triangle, here, if I look at two sides, let's just say I look at AB and BC. Or in other words, if I look at the 12 plus 5 side, I'm picking one side and I'm picking a second side. The rule is saying that two sides has to be greater than the third side in order for this to be considered some type of triangle. Well, let's look here. 12 plus 5 is equal to 17, and that is greater than the third side, which is 13. So because this statement is true, that means that triangle ABC is a triangle. Okay? I hope you have that copy. I'm going to erase that. All right, here we go. Let's look at another example of how we could do that. Again, I say, it doesn't matter which two sides I pick. If I pick side AC and BC, or in other words, the first side is 13 plus the second side, which is BC, of 5. In order for this triangle ABC to be considered a triangle, this is side 2, it has to be, these two added together have to be greater than that third side. Well, what's the length of the third side, which is AB, is 12. Is this statement true? 13 plus 5 is going to be 18, and 18 is greater than 12. That means so far this is a triangle. Now I need to check the last two sides. So far, the first and second side are greater than the third side. And we did this one here. The 12 plus 5 was greater than the 13. That was true. Now I'm going to check the last set. Well, I can cheat right here and easily see that if I add these sides, AB plus AC, that's 25, and that's greater than the third side of 5. So therefore, this is going to be considered a triangle. Do that again for us. Let me erase this and then go back. All right. Here's the first step. I've got to check all three to make sure that this works. Here's the first step. Step 1, I'm checking the first two sides. I'm checking AB and BC. So 12 plus 5 must be greater than that third side. That's what the theorem says. And the third side is 13. Well, let's check and see. Again, 12 plus 5 is going to be 17. It's greater than 13. This checks out. So far, this is a triangle. Okay? Let me check the next two sides. Here's my second check. My second check, I'm checking BC and AC. And I'm trying to see if BC plus AC is greater than AB. So here I am. I'll put a little line here so you can see the difference. So I have 5 plus 13, and it needs to be greater than this third side, AB, which is 12. When I add them together, 18 is greater than 12. So because these two are true as well, so far, this is still a triangle. Now I need to check the last remaining one. And my third remaining one is simply going to be the AC and the AB. And that's going to be 13 plus 12. It must be greater than the 5, and it is because 25 is greater than 5. Okay? If all three checks, you must do all three checks. The first check, the second, and the third check. You have to do all three checks. If all three checks are true, then this is going to be considered a triangle. Yes. If you only check one and it's a yes, these two could be false and you will get a wrong answer. You have got to check all three to verify that this is considered a triangle. And back here, what is this saying? Now I uncover because I use the variables or the side lengths instead of the numbers. Okay? Here I put AB plus BC. So AB plus the BC, which we check, is greater than the AC. And if I throw the numbers in, AB is going to be 12 plus BC, which is 5. And it is greater than the 13. So this one checked out. Now I'm doing AC plus the BC, and it has to be greater than the AB. And the AC is going to be 13 plus the BC, which is 5. It has to be greater than AB, which is 12, and it is because it's 18, which is greater than 12. So this one checks. And then finally, as I stated, you have to check all three. AB plus AC must be greater than BC. AB, by substitution, is going to be 12. Plus AC, which is 13, and it must be greater than 5, and it is. Therefore, this is, yes, a triangle. Okay? And that's 5, part 2.